Hello everyone, my name is Jørgen Myggen and I'm the business manager of TouchGFX. I'm really pleased to welcome you to this webinar, 1 hour webinar with a title of Less Power Consumption and Unbeatable UI Performance on the TouchGFX plus STM32L4 Plus solution. This is hosted by Draupner Graphics in close collaboration with ST Microelectronics. Just a minute. Okay, and here we have the agenda for today. In a minute we will kick it off. Bertrand Denis from ST Microelectronics will walk us through the presentation of the brand new STM32L4 Plus. After this, I will give you a short introduction to TouchGFX before I will hand it over to our product manager of TouchGFX, Jesper Hedegaard, making a live demonstration of how you can actually start programming with TouchGFX on the new STM32L4 device. Later, we will have a bit of tips and tricks for limiting required resources. We will follow up with a business model of TouchGFX and your contact points contacting ST as well as Draupner. We will finalize with picking up questions. Actually, as we go along during the session, please put down your questions in the formula you have available on GoToWebinar, and we will actually try to in writing answer all the questions as we go along, and we will pick a few up verbally. So we might not be able to actually cover all questions as we are really big group at this webinar. So let's kick it off, and I will hand it over to Bertrand, and you can I will make you a presenter, and you can take it from here. Please go ahead. We see your we share your screen now.
Okay, thank you. Thank you very much for inviting us to this webinar. So my name is Bertrand Denis. I'm product marketing on the STM32L4, and I'm going to present you a new microcontroller called the STM32L4 Plus, which is a new member of the STM32 ultra low power family. So here are the key messages of the STM32L4 Plus. So why plus? Plus because in performance we have stretched the STM32L4 architecture to gain 50% of performance and reach 120 MHz with Cortex-M4 and the floating point unit, while keeping the best-in-class ultra-low power figures. Plus also in terms of graphics and innovation, with more innovative peripherals for graphic acceleration and display connection. Plus also for more integration, up to 2 MB of flash and 640 KB of SRAM, a lot of digital and analog peripherals, with a large choice of packages and with a size down to 5 by 5 mm. And finally, the last message is regarding the great investment for the user because of this pin-to-pin compatibility all across the STM32 family, and also the user can reuse the large STM32 ecosystem. So the first message is relating to the STM32L4 Plus is regarding the greater performance. The STM32L4 Plus provides 50 more of performance versus the STM32L4 while keeping its excellence in terms of power efficiency. So it runs at 100 MHz, 150 drive-through MIPS with a Cortex-M4 and floating-point unit. But it goes also with 2 DMA, as well as a number of high-speed peripherals. And what I want to mention, because it's new in this product, is the 2 octoSPI supporting both NOR flash and Hyperbus SRAM. So while it's very good in terms, it's better in terms of performance, the STM32L4 Plus has kept the best-in-class power consumption figures from STM32L4 with a full flexibility. The user can select the mode depending on the wake-up time, the state of retention, and the number of sources required. This slide here shows some examples of ultra-low power modes, and as you can see, a lot of flexibility is provided to the user. The STM32L4 Plus shows also a very low power consumption in active mode, down to 43 microamps per megahertz. And the best-in-class power efficiency is proven by the score obtained in the ULP bench, both on core profile and peripheral profile. We are achieving 233 ULP mark CP, so for the core profile, and 56 ULP mark PP. So this is really something best in class in terms of power consumption, and again, it's a product running at 120 MHz, so it's really unique in the market. The second message is regarding graphics. So plus means also more graphics. So we have the Chroma-ART accelerator. The Chroma-ART accelerator is a 2D graphic hardware accelerator which allows to release the core to provide advanced graphics. Several examples showing this feature are available in our demos, both on Discovery Kit or Evaluation Kit. And you can set on or off the Chroma-ART and check the impact on the CPU load. So very interesting features which allows to release the core and better in terms of graphic capabilities and also reduce the power consumption. Second thing is regarding graphics. So we have embedded on this microcontroller a large choice of display interfaces, which is quite unique for an ultra-low power microcontroller. So we have both the MIPI DSI, which is, for example, shown in the Discovery Kit. We have the TFT controller interface, and we have also the parallel display interface with the FSMC. So a large choice of display interfaces. The STM32L4 Plus embeds a new innovative IP called Chrom-GRC. This IP enables to minimize the SRAM size required for a frame buffer in the case of a non-squared display. Typically, when you are using a circular display, you are losing 20% of the memory as the frame buffer needs to be squared. So the Chrom-GRC, with the Chrom-GRC, you are saving 20% of the memory size in the SRAM. And thanks to the large SRAM size embedded, 640 kilobytes, you can directly handle big display. I mean, for example, we can support 400 by 400 with 20 a 24-bit MIPD side round display without any external SRAM. So thanks to this embedded 640 kilobyte of SRAM. Or also a wide QVGA 16-bit TFT display without any external memory. So obviously, it's again cost, a BOM cost for the customer, as well as a power consumption gain for the final application. So yeah, that was the second message regarding the STM32L4 Plus. We are embedding more graphics capabilities in this device. First message is regarding the eye integration. So here is the block diagram of the STM32L4 Plus. As you can see, a lot of peripherals and features are embedded. A lot of communication peripherals, USB, UART, SPI, etc., CAN. But what I want to highlight is again the fact that the STM32L4 Plus offers a large memory size, 2 MB, up to 2 MB of flash and 640 kilobytes of SRAM, and with a package which can be down to 5 by 5 millimeter. The final message is regarding the great investment. So if you look at all the STM32 portfolio, so it offers an extraordinary variety of compatible microcontrollers based on ARM Cortex-M cores, Cortex-M0, M0+, Cortex-M3, Cortex-M4, Cortex-M7, giving developers a lot of flexibility to find the perfect STM32 microcontroller for their applications. More than 800 part numbers are now in production in the STM32 family. So the STM32L4 Plus is a great investment and benefits from the pin-to-pin compatibility across the STM32 family. So now if you have a look at the ultra-low power family, you can see that there are already several members. So first one is STM32L0, which is cost-effective microcontroller based on Cortex-M0+. The STM32L1 with Cortex-M3, which has a broad range of products. The STM32L4 that we launched 2 years ago, bringing more performance and excellence in ultra-low power. And now we are adding STM32L4 Plus. And the STM32L4 Plus completes the ultra-low power family by providing more performance, more memory, and more packages. Here is the portfolio of the STM32L4 Plus. It is available now in 2 MB or 1 MB of flash, and from 100 pin up to 169 pin in QFP, BGA, or CSP packages. So a lot of choice. You can also select with or without the crypto version, and in addition, several options exist with or without the MIPD or the TFT interface. And the good news is that all this portfolio is fully available and in production, and so it means that you can order it now. Some words about the STM32L4 Plus ecosystems. In terms of hardware tools, a low-cost Nucleo board for flexible prototyping is available. Also, discovery kits with more features embedded, like a MIPD round display, can be used. And finally, a full feature evaluation board is available as well. For the software tools, the STM32 CubeMX can be downloaded on our website. It enables to select the product and the package that you want to use, configure the peripherals, and generate a code in order to facilitate the design phase. You can also get an estimation of the power consumption even before starting the design. We are providing, as usual, the embedded software. The first firmware layer is made up from the low layer driver. That is to say, the hardware abstraction layer, HAL, and the low layer, LL API. The HAL implements high portability between STM32 series, while the LL API brings the performance aspect to the STM32Cube L4 Plus offer. The HAL abstracts the STM32 series from one another thanks to the highly portable sets of API, so ensuring an easy migration path from one family to another. While the low layer API are a lot closer to the machine and constitutes a lightweight, high-performance, expert-oriented firmware stack for maximum dynamic reactivity and flexibility. For more convenience, the STM32 Cube L4 embeds firmware, which comes from with a set of middleware bricks like USB, file system, etc., and graphics. We will talk more. TouchGFX will talk more about their solution. And in addition, of course, numerous examples are provided to help the customer to understand how to use the software. So as a conclusion, the STM32L4 Plus is a unique microcontroller providing more performance while using the state-of-the-art ultra-low power technology. It provides more graphics and more integrations, 2 MB of flash and 640 KB of SRAM. And it is a great investment because it is a pin-to-pin compatibility up to the rest of the STM32 family, and you can reuse the STM32 large ecosystem. You can get more information on st.com/STM32L4 Plus, datasheet, reference manual, software, a lot of application notes, technical training, which is very useful if you want to go deeper on the STM32L4 Plus. Thank you.
Thank you very much, Bertrand, for this overview of this exciting new device from ST. A few questions is coming in, and one is asking about target applications. What areas of applications are this new device is focusing on?
So a large choice of application, but obviously mainly all the application running out of battery. To name but a few, wearable device. Of course, with the display capabilities, also a lot of can be interesting for HMI display, as well as industrial sensors, because industrial sensors request more and more memory, more and more performance, and this is unique features in the market. Also for metering. So yeah, let's say all the battery operating system and the STM32L4 Plus complements the big portfolio that we have already on STM32.
Okay, good. There are a few other questions, but yeah, we will probably answer them in writing. And from our perspective, our GUI perspective, yeah, we see a really powerful device running battery-driven applications, and we have been working with it for some time now, and have a demo available, and you will get access to this demo. Watch a video on later slides. I will take back the presentation. And I think I'm back here. And and I will move on to the next, giving you a short presentation of TouchGFX. TouchGFX is a license-based software tool. What it does is that it's actually making you capable of creating smartphone look and feel UIs based on microcontroller hardware. In order to give you an idea of how customers are utilizing the benefits of TouchGFX, making high-end UI products, I will share a few customer cases here. The first one is the French company Somfy, making a remote control for shutters. What Somfy needed here to save costs and to achieve a long battery life, first of all, they selected a black and white display and a standard purpose microcontroller from ST. With a combination of really nice graphical design and the capabilities of TouchGFX, a really unique Somfy look and feel was created and realized on this platform. And you can read more on our website about this. The next one I will share with you is the US-based company iBit, making a smartwatch with healthcare functionalities. Here for iBit, it was extremely important to achieve what we can say the real smartphone look and feel, and beside this, again, a long battery life. A really high resolution, great display, a round display with a resolution of 400 × 400 was selected, and to run it, an STM32 device, the F469, a Cortex-M, was selected. And TouchGFX was proven to be the best performing GUI library, and best performing in the sense of getting the highest level of smartphone look and feel. So this is instant responses, gesture recognitions, smooth transitions, and cool animations. So here they actually achieved the smartphone look and feel they were aiming at. These were two use cases within the wearable sector, battery-driven applications. TouchGFX is aiming at a lot of other stuff, but for this seminar, it's the battery-driven we are focusing on. You can see much more in our website. A few words on how we actually are stand out from competition. TouchGFX was invented back in 2009 to run on microcontrollers. Everything we do, we focus on limit the required resources, and this is in terms of computing power and memory needs. So therefore, TouchGFX gives you the unbeatable UI performance. And TouchGFX is a very flexible tool, open to integrate with any environment and other tools you may wish to use. So so it's a flexible tool, making you capable of being in control as a developer, creating anything. And finally, TouchGFX comes with a set of tools, free of charge, supporting the process from idea to UI product. One of the tools is the GUI builder, the drag and drop GUI builder with automated code generation. It supports both the graphical designer in prototyping and specification tasks, as well as it is supporting the developer in fast implementation. We are continuously adding features, making TouchGFX easy to use. And we will now actually demonstrate how you can actually get started with TouchGFX. And I will hand the presentation over to Jesper. You just take it. Yeah, you see the screen?
Yes, great. Thank you, Jørgen. So now for the demonstration of how to actually get up and running, starting to use TouchGFX. So here on my computer I have downloaded the new version, the 4.9.2 TouchGFX installer, installed it here. I have ST-Link utility downloaded and installed on my PC as well. And actually that is the only two tools I need to get up and running on the ST hardware. So let me try to open up the designer and let's see if we can do a demo. Okay, so here is the startup screen. We have our create new application window open. For me to create a new application, I have a few things to select. So a name and a directory for my project, and then two components, namely the application template and the UI template. So let me explain a little bit about these two components. So one of them is the application template. This is where I want to run this application and how I want it to be structured on my in my project. So right now the simulator is selected. So if I go and push create, I will have a project that runs only on the simulator on my PC. That is not what I want. So I can click here and I get an overview of all the supported boards from TouchGFX. I switch to ST Microelectronics and I see a broad range of devices that are supported. Today we are focusing on this device here, the L4. I can press the info button here and I can read more about the actual application template, what is supported. So here we can read that it supports IAR and GCC. It runs on FreeRTOS and this resolution and split depths and so on. We see a nice picture of the actual board. If I want to read more on how to get up and running on this, I can press this link here and I will see a installation guide for this. So if I use IAR, I need at the moment a patch for IAR. Here's how to download and how to install it. We need ST-Link utility. You need a brand new version of ST-Link utility. You can go here to get the information how to actually download this from ST. Okay, that is the board I want to select. So now I've selected it as my application template. I can also choose the starting point of my UI. So by default it's a blank UI, but I can also go here and see also a broad range of actual demos that I could examples that I could start out from instead. If I want to learn how to use animated image, this would be a good place to look. I can press here and see the matching UI templates for the current selected board, and right now on this display we have this TouchGFX watch demo. But for now I would select the blank UI since I want to start from scratch. I press create, it downloads the components and combine them together and create the new project on my disk. Okay, so here we have the designer with a empty one screen, and it is empty, so I see the empty canvas here. Okay, so I'll try to start up my project. I will add a background. For this, I select a widget in this list of widgets over here. It's a tiled image, meaning that I can set an image, and actually I can stretch this, not stretch it, but expand it so that the tile will repeat itself and be my background for this screen. I'd like some images in my application, so I got some on my desktop here, so I have images here. I'll just select them and drag them to my image picker here. So now I can add an image to my canvas as well. I can select one of the imported images. Let's select TouchGFX as it is a TouchGFX application. I can add it, put it here. Now I can. I have my first screen here. So let's try to run the simulator, see if everything is okay. So I can invoke that from within the designer. Of course, I can also compile it elsewhere. I'll show you that later. But here I have the simulator. It shows the screen that I have created. Not very interesting right now, but let's change that. So in TouchGFX, you have the widgets over here, and you have your screen property here. On the left side here, you have the overview of your screen, the added components. So I have my image here. It's called image 1. And I can select it, and I can see the properties for it over here. What I also have on this screen is an interaction pane here. So an interaction is a trigger and an action. So when something happens, I want something else to happen. So here on my trigger, I have for this screen a hardware button is clicked or screen is entered. So let's select screen is entered, which is an event that is triggered when the screen has appeared. And the action I want to execute is, let's select move widget. So I can, when this trigger happens, I will move a widget, and the widget I want to use is the image 1, the TouchGFX logo. I can select a position where I want it to move to. This is y -100 is above the screen. I can select a easing equation for this for the movement, and I can select that this can be used as a trigger for another interaction. So let's try to run that as well, and hopefully, I do not know the frame rate that you received this webinar with, but you should see an animation of the actual image moving upwards. Okay. So now I have that, a little bit more interesting, but not that interesting at all. So let's try to change screen. So this could be a splash screen or something like that. So I add a new screen here. I can add a background to that so we can actually see it. So we have something on the screen. I can go back to screen 1 and add a new interaction. This interaction, so now I have another interaction is done as a trigger, and that is interaction 1, the one I just did. And what I want to do is to change screen. I want to change it to screen 2, and actually that's it. So I can compile again, run the simulator, and you will see it in a short while. So now it compiles and actually executes the TouchGFX application, and you can see I changed to the new screen. Okay, so I'm ready to make my, let's say, main screen here. So what I want to do here is I want an image. Let's select an ST logo for this. I have it here, and then I could select I will select a slider, which is a widget supported in TouchGFX. We have a set of styles, a default looks that you can select for your slider and whatever widget you choose. Of course, you can and you should use your own graphics, so you can set the exact images that you want to use for this slider. But I'll go with this default style here. So now I have the slider on my screen 2. See the animation again. We change here, and I have the slider doing nothing, but I can move it around. So what I could do here is add an interaction here, and since we have a slider, I have a new set of things I can select. For example, slider value changed. I'll select that one, and it's the slider 1. What do I want to do when this event happens? So I can do a lot of things. I could change screens, or like I just did, I could move something. But what I actually will do here is I want to execute some C++ code. I have two options there. I can either have this call a virtual function that will be called, and I can go and write the code in my editor. I can also, since it's a small thing I want to do, I can also actually just select execute C++ code and write the code here in this small window. So this is for smaller changes that you want to do. If it's a more advanced thing, like, for example, communicating with your backend system and so on, this is not the place where you should do it. You should use the virtual function and write it in your editor. But for now, I would like to change the alpha value of my image, the ST image. So if you have a look up here, it's called image 1. So I can say image 1 set alpha. So this is a function on the image widget. The value I would like to use is slider 1 get value, which is the current value that is reported by the slider. So this should update the alpha value of the image. One thing I need to do is to call in validate, which will tell the framework that this image has to be redrawn. So now let's execute again, compile the program, and launch the simulator. Yeah.
We have a.
So now, wait a minute with that. So here you can see now I am adjusting the alpha value of the image. Actually, it's not fully solid here, so something is wrong. And what is wrong is that this slider here reports, so it has a property here saying minimum, so when it's to the left it reports 0, and maximum to the right is 100. But actually my alpha value should be it's an 8-bit value, so I should report 255 at the right end. So let's change that and run again. Okay, and now we see it becoming full solid to the right. Okay, so we have this application, and we are have seen the simulator here. But since this is all about the L4, we would like to actually execute this on the L4 hardware. So here, the application template that I selected for this L4 has been set up so that when I press Run Target here at the right upper corner, it will cross-compile it for the ST hardware and actually use ST-Link utility command line tool to flash the board. So I'll press that, and it will start compiling, as we can see here, and it will flash it afterwards.
Okay, good. A lot of questions are coming in, and some of them we are actually capable of answering in writing. A few of them is addressing IDEs, and one is asking here, is TouchGFX supporting Kyle and J-Link? This is another one, Jesper, is what IDE can I use?
Yes. Great. Okay. So yes, is it supporting Kyle? That depends on the application template for the particular board. This particular board, at the current moment, supports IAR and GCC compilation. Kyle is also supported in general by TouchGFX, so there's a library for linking with Kyle, and normally that is also included in our application template. Since this is a brand new application template. It does not at the current moment support Kyle, but it will in the very near future. IDEs to use, I would like to actually show that. So what you can do in your designer here is that you can press browse code. That is, give me the directory where your where this current project is located. So it is here. A few directories here. So we have our code here in the GUI folder. We have our assets, that is the images and so on we want to use. We have the target folder here. So here we can see we have GCC. We have a makefile for that. And we have IR both in version 7 supported and version 8. We have a simulator. It is a GCC makefile and a Visual Studio project. Actually, I'll try to start the Visual Studio. That might take a while, so let's wait for it. So these are updated automatically by TouchGFX and the designer. So what you can see here is that when I open this application structure up here, we see the screen 1 and screen 2 and the files that are needed for this. These screens are here. So if I open screen 2, I can see this is my version as a developer version of screen 2 view. So here I can add things I want to do. In the base class that I can jump to here, it is the part of this screen 2 view that is owned by the designer. So this will, you should not tamper with this. This will be updated when you generate code from the designer. You can see here we have the tiled image 1, and slider 1. This is the C++, the source file for this view. You can see here it's generated by TouchGFX Designer. And actually we can see my code that I wrote in the designer is embedded here. But of course you will not be able to do everything in the designer, so you will need to write a lot of, not a lot, but your application, the part that you will write in code, the logic and so on, will be in this view and the presenter class you also have here. When I create a new screen, this will be updated automatically in the, I can try to do it in the designer. So if I add a new screen here, generate code, and go back here, you can see I should reload, and now I have screen 3 and the new files here. The same goes for IAR and Kyle. You can have the designer update that those projects as well, so that you can make your changes in the designer, go and write your code, enter IAR and compile and flash from within there without managing all the new files and so on. To the question about which IDE are supported, so these are directly supported from TouchGFX. But of course, since TouchGFX and a TouchGFX application is C++ code and nothing else, you can also set up a, let's say, an Eclipse project, add the files there, and call our environment to use, for example, GCC and make to build your application and run it from within, say, Eclipse or anything else. So it's not a closed system. You can also just use an editor. If you're a Emacs guru, you should just use Emacs, and you can use our build environment to actually build your code. So we have a build environment here, a shell. So we can go to our TouchGFX project. Let's call my project here, and here I can say make simulator GCC make file, and I will make my file, and I have my output, and I can execute it from there. The same goes for Visual Studio. Of course, I can build there, and I can run my simulator and debug and so on using the same way that I always do in Visual Studio. The same goes for IAR and Kyle. It's a C++ program that you flash the board with, and you can set breakpoints and so on. Yes. Okay, so that was a brief run through of the actual how to get started on TouchGFX. If you want to have more information, you can go to our website, touchgfx.com, or support.touchgfx.com, where you will see our help center, where we have getting started articles, knowledge base articles about all the details in TouchGFX. You can visit our forum, where we have a lot of active threads about all sorts of things. Yes.
Thank you, Jesper. It's very good. I will take it back and carry on with the presentation. A little bit about a targeted platform and required RAM resources. Also, actually answering questions about operating systems and what is required. We are targeting embedded display solutions up to around 10-inch displays, but actually we have no limitation in TouchGFX. It's more related to the hardware. For operating systems, yeah, we run on any. The demos you see from our site, we are using FreeRTOS, but we have customers running on all kinds of different RTOS. You can actually run on the bare metal without an operating system. And we actually have upcoming Linux support, so this is also an operating system you can use. A standard hardware setup for an UI application, you have this here to run the display, and microcontroller or microprocessor, some flash to store images primarily, and some RAM to have the stack of TouchGFX, the application, and frame buffers. The normal setup is using normal setup is using 2 frame buffers. In this case, we can actually draw to 1 frame buffer and transferring the other to the display. And having a really smooth animation with high frame rate. And yeah, the frame buffer is actually the part that takes up most memory here, and we were focused on this. We have some general numbers of what kind of memory we need, and let's focus on the RAM usage. The library itself and application, yeah, maybe around up to 50 kilobytes, but the frame buffer, depending on the number of pixels, the resolution, and the color depth, yeah, we can calculate. In this case, I have an example of an 480 times 272 16-bit color depth and 2 frame buffers. We are ending up at around 520 kilobytes of RAM for 2 frame buffers. And this is actually something that we see a big push in the market, primarily for the high volume products, actually needing applications without external RAM, saving cost and as well as saving power consumption. And what our solution from TouchGFX is, well, yeah, first of all, if you have available RAM in internal RAM, place 2 frame buffers in internal RAM, and you will have a really smooth and great running application. And second option is actually to utilize RAM in the display. Here you can place the 2nd frame buffer, and again have a really good setup. And this is actually the setup we have on the ST Discovery Kit with a new L4 Plus device. having one frame buffer in internal RAM and the second frame buffer placed in the RAM of the display. But with the TouchGFX technology, you will actually be capable of running with only one frame buffer and place this in internal RAM. You can still have a really nice looking smartphone UI. There's some limitations, but actually, yeah, you can actually go to the link here in this slide and read a little bit about this, get access to video and actually code examples. And talking about RAM needs and the frame buffer, it's of course really important to know what it takes to run the 16 or 24-bit applications. This is what you need in order to talk about a smartphone look and feel, definitely 16-bit. For the application running on the Discovery Kit here to the left, it's running a 24-bit color, and the resolution 390 times 390. The availability of RAM in the new L4 Plus device, yes, 640 kilobytes. Yeah, this leaves sufficiently RAM to run with one frame buffer internal and one frame buffer in the external in the RAM of the display. So for you getting started, it's really easy. You can go to our website, get access to TouchGFX evaluation version. It's a fully functional version, and you will get access instantly. With this, you can start exploring the available application, and if you have the kit from ST, yeah, you can actually start seeing your applications running on real hardware. And this you can do before you actually go to buy a license and start your development process. Jesper also shortly mentioned that we have a lot of free resources on our website helping you getting started session and a knowledge page, and not less the community where you can put in questions. So please be free to use this. The business model of TouchGFX, it comes in a fully functional version, the evaluation version, and you can get access to this from the website. Moving into development phase, you need to buy a license, and here we have the license model. It's focusing on the end product. So you buy a license per product. So if you have a microwave oven, yeah, you buy one license for a microwave oven, and if you have another, you have a dishwasher, you also buy a license, a new license for the dishwasher. We have two production volumes. If you have an annual production volume of up to 3,000 per year, you pay 5,000 euro. You pay this one time, and you can produce up to 3,000 units every year of the lifetime of this product. Included in this 5,000 is the first year of support and software updates. Second year, it's optional if you want to continue with this. So again, you pay 5,000 euro year one, year two. Yeah, you can pay for the update agreement if you like. If not, you pay zero the second year and so forth. If you need to go above 3,000 units, up to 50,000, the one-time payment is 15,000 euro. Above 50K, we will make a customized license. This we will do also if you have a lot of different product lines. We will customize the license matching your needs. And the tools coming with TouchGFX is free of charge, so there will be no limitations in number of developers. Finding your contact points, please go to our website. Here we have listed all our distributors, all our partners around the world. It's not completely covered, but we have a lot. Go to their websites and get contacts, your local contacts, or you can go directly to us and to me. You have my email address here. And for ST, yeah, go to your local ST office or ST distributor contacts as you're used to. So we are now having a few 5 minutes for picking up questions. And yes, but you have a question. Well, you have an answer on a question.
Yes. So it has been asked if we use the Chroma-ART for this, or how to use the Chroma-ART, the ST graphic acceleration. So for in this application template, the port for this board, the Chroma-ART is utilized fully. So when you, for example, draw semi-transparent images, the Chroma-ART will be used, and the low micro or MCU load, as mentioned earlier in the slideshow, is achieved. And you, as an application developer, you do not need to think about this. This will happen automatically when using TouchGFX. The same goes for the Chrom-GRC. For this board, the Chrom-GRC, the optimization for round displays is used. So actually, the numbers that were shown by Jørn earlier for the size of the display, for this demo board, which is a round display, you have a 20% cut in the RAM usage. So you do not need 456 kilobytes, you need 365 kilobytes instead, which is a huge save when talking memory inside the microcontroller. We also had a question if this application could go to if we could flash the board with this application. Actually, I pressed the run target button, but I never showed you that it actually run on the actual hardware. I can try to do that. I have a webcam. I don't know how good the quality will be, but now I'm trying to share it, so maybe you will see me. I have the board right here. We have the application running, and I can set the alpha value here.
Okay.
So no. Hopefully.
Additional question here, Jesper. What about my own target hardware? How do I actually get that up and running? Can I do that easily, as you can with it?
Yes. So even in the evaluation version of TouchGFX, you can change the hardware abstraction layer. So if you have a custom board, or if you have modified your discovery board from ST, you can base it on an application template that resembles the one that you have, and then you can go and modify it. It's in source code, so you can change the configuration and the use of drivers and so on. You can also start from scratch, doing an entire port. Of course, this will be a bigger task than if you can reuse some of what we have done. But this is doable, and you can do it in the evaluation version, so that you can check your TouchGFX application on your real hardware. All of this is, of course, described in our help center.
Great. Yeah, we are close to closing down here. And Bertrand, one question for you, and a final comment. That's a question about what are actually the main differences between the new L4 Plus series and the existing L4. What is actually the main difference? It's both an Cortex M4 core.
So the major difference are the S4 Plus brings more performance, and as well as more memory and more graphics. Here are the main difference versus the STM32L4.
Okay. Okay. It's okay. We will finalize, and as it also has been answered, both the presentations as well as the recordings will be made available to you after the seminar here, and the questions we haven't managed to answer yet, we will answer to you, so all questions will be answered. And please come back to us with further questions and comments. We are here to support you and our support teams around the world. Thank you for now to all of you.
Thank you.